Hello, everybody, and welcome to the Pennsylvania Earth Sciences Association, AMPSA presents with the importance of trace fossils, their role in science, and specifically with the Stephen C Minkin Paleozoic footprint site. Now, first of all, a huge, massive thank you to the wonderful, lovely people at the Alabama Paleontological Society. None of this could have been possible without their gracious assistance, and so thank you, thank you, thank you, and thank you again, and henceforth for all of the wonderful work that they have done with providing information and photos to me for this. So now let's look at a couple of fossils. Fossils, first of all, are not just skeletons. Skeletal fossils, as awesome sauce as they are what are called body fossils. Now, there are other kind of fossils. Another major kind of fossils are what are called trace fossils, which are those that preserve the activity of an organism. They're not the physical body itself, but they're basically something that preserves the remains of what the organism did. So, say a footprint or a burrow or a mark or a trace, more or less, that's, say, a fin or a tail or a claw made in the ground. Things like that are trace fossils. Now, while they're not, say, a bone, they're still just as important and in some ways even more important as a body fossil. Now, the study of these trace fossils is called ichnology. Now, what do ichnologists do, and really why is this important? Well, ichnology allows us to determine how an extinct life form lived. Things from environmental indicators to even the stance and walk of extinct creatures. A very important example of this currently is the stance and walk of dinosaurs. Two very important examples that come to mind immediately are Tyrannosaurus rex and Spinosaurus. It seems almost like pretty much every single new example that comes out with a new Spinosaurus fossil, people keep arguing about how its stance and walk changes when it comes to footprints and other things. So if you can picture a dinosaur trackway, just imagine if you could have the footprint in front of you and you can see how really the pressure is put down. If you can picture the pressure of the footpad and other things, then you know how the dinosaur put its foot down. You know how its knee was bent and how its hip was then angled. If you could then basically, yes, there's a bit of deductive reasoning involved, but still you have a concrete example, no pun intended because it's rock, of course, of how this animal walked. And then thusly you're able to also tell how far apart it walked, and then you can also tell furthermore how fast it walked and then how fast it ran. So these are some very, very interesting examples giving us some very important insights to the lives of extinct organisms, and they record exact snapshots of their lives and how they were lived. Now, some of these snapshots are things like this. Now, I'm a bit of a reformed stammerer, so if I stutter a little bit over this, I apologize in advance. This is a very early example of a trace fossil. It's from the genus See, there I go. Sorry, folks. Treptichnus. Now, this particular genus is one of the several ones that is found at this site right here, the Stephen C Minkin Paleozoic footprint site. It's formerly called the Union Chapel Mine. Now, first, foremost, henceforth, and forevermore, this is not a public site, so I don't want to hear about any y'all going out here with your tools and shovels and picks and anything. Don't go doing that. It's only accessible by permission. So this is one of the sites that the Alabama Paleontological Society, known for short as the APS in this is one of the things that the APS themselves has permission to go to. And so, you know what, unless you get permission by them, don't go in there. So just stay out. And that photo, by the way, is by permission of one of the lovely people involved. So thank you to Angela Reynolds Drew. That is actually from the site itself. Now, the site is in Alabama, as we've just said, specifically in Walker County. Now, our story begins about 315 million years ago during a wonderful and very significant period called the Carboniferous. So we're looking here at the mouth of a river. Now, so this river flowed from the ancestral Appalachian Mountains and met the adjoining Warrior Basin, And not to go too much on a side note here, but we really need to name bodies of water and other things like this better nowadays because, I mean, just naming things, the Warrior Basin, stuff never gets named this cool nowadays. That's just, I mean, that is a totally awesome name. So, back during 350 million years ago, so high tide, low tide, back and forth, what have you, local animals would walk onto the mud flats during low tide. They would leave their tracks in the mud and then they would go back and forth. And so over time, high and low tide, it would leave records within the sediments of these various species of animals. Lots of species of animals, as it turned out. Now, this area was right next to, being the Carboniferous, a coal forest. So, like many other Carboniferous regions, this area also then teemed with plant life. Now, you may see in some sources a couple of people that sort of poo poo this site. Personally, I think that they're just jealous of really how awesome it is. Folks are just saying, oh, well, some of these plants aren't really found here exactly. They must have just maybe got like washed down from other locations. It's pretty much a freaking coal forest. I mean, forest is literally right in the description of it. It's, sorry, there are plants naturally there, people. So, but again, some of these photos are from Angela, and I mean, just absolutely lovely specimens there, as you can see. Now, one thing about the Carboniferous is when you think about the fossils from here, oftentimes people think of just that, the plant fossils. So, why is that? Why do people not think of faunal fossils as well? Well, you do have obviously animals during the Carboniferous. But the thing with these coal forests is that the soil is very, very acidic. So, my friends, it does not really lend to the best of preservation chances for these creatures. So that is why during these times you happen to see a lot more so of plant fossils. Yes, also too, this is very much the age of plants in many ways. So yeah, it kind of is the law of averages, but also the same just because of the geochemistry involved. That's why you happen to see a lot of plant fossils and not as many of the animals. Now, what you did happen to get forming is a lot of what is called today the Mary Lee coal zone. So, all of these plants, all this organic matter, formed a lot of coal, which was then mined under the Mary Lee coal zone. Now, what was found in there was over 2,000 approximately. The number varies greatly depending on what source you read. Over 2,000 species of fossils were eventually found here. Now, on the right, you have an example of a local miner's bathhouse. So, when everybody would get cleaned up at the end of the day, they would go pop off in there and go take care of things. And the mine eventually, of course, did sadly shut down for all of these workers, but things did still continue in a way. Now, what did continue was that the mine got to be known for having a couple of fossils in it in the general area. Now, some of these fossils included arachnids, arthropod feeding traces, brachiopods, fish swimming traces, insects, a couple of small reptiles, various plants, and in the last several years, there's been managed to found larger tetrapod tracks as well. Now, a couple of some images from there. You have some of these amphibian trackways. So basically, you can kind of see them coming down from the corner, and it's almost like they found something like, oop, I don't want to see that, and then turned right around. Here are some other different amphibian trackways literally crossing each other. Here are some of those traces of the fish fins from earlier. So, yes, that is still a fossil. It's a trace fossil, but you can actually see the marks that the fin made in the sediment. Trackways from the horseshoe crab. These are insect feeding traces. Now, this specimen is from the area, but this exact specimen itself is from Arizona. I couldn't find a good photo from locally. Now, this genus is kind of interesting. It's a very common one at the Minkin site, and a lot of people argue about it. Some folks give its percentage to be a very, very high one amongst the fossils. Others say no, that's very overestimated. Its percentage is a bit lower. But really, with a site that has this much volume, you're gonna find a bunch of, people are gonna argue about something. And in the case of the Minkin site, this is one of those somethings. Now, here is one of the examples of a small amphibian that you find there, but like the specimen earlier, this one is same genus that you find there, but this particular specimen is from a different state, namely Massachusetts. Here are some various burrows that you can find. Now, does this site qualify as a Lagerstätten? Personally, I think yes. Now, for those that don't know what a Lagerstätten is, it's a totally boss, absolutely awesome thing. So it's a German word that it basically references a fossil site that is just the best of the best, an absolute motherlode of prime fossil material. A couple of people are trying to push to have the Minkin site qualified as a Lagerstätten. There is a little bit of back and forth about that. Again, I think because a couple of people are sort of jealous about it. Folks thinking, oh, that place is in they're in Alabama, they're in the United States. What do they know about good fossils? And there's a little bit of jealousy going on there. But really, I mean, this place is completely awesome. It's world famous. People go from all around to see it. So if you're around in the area, I highly recommend it. And if anybody out there has any pull, go out there and get this place classified, gosh darn it. So now, how did the Minkin site get to be known as the Minkin site? Well, so back in 1999, there was this high school teacher, Ashley Allen. He had been talking about how he wanted to go looking for fossils at was then the Union Chapel mine. But he didn't want to get into any trouble because he had heard about, well, it's always better to be safe than sorry, right? And in his class, this student piped up and was like, hey, my family actually owns that mine. You'll be fine. Don't worry. Go ahead. And the student basically gave him permission to collect there, which of course was convenient. So Mr. Allen went out there and he found fossil tracks. And he reported these fossil tracks to the Birmingham Paleontological Society, who have since changed their names to our friends, the APS. So the APS and local geologists, including the late Steve Minkin on the left there, led an effort to have the site preserved. Now, why was this such a time crunch? Well, according to the law, mines had to be reclaimed, which, yes, is a very, very important thing for the environment. You need to have mines reclaimed for various concerns, say certain chemicals that have been leached into the soil and the water, and also different things that say different plants and animals have been exposed to. But this is a very unique concern. This is a concern that is very unique on several fronts. And so a lot of people were fighting for a while to have this site preserved instead of reclaimed. During this fight, Minkin passed away far too young, far, far too young, on February 20th of 2004, God rest his soul. And the site was dedicated in his memory on March the 12th of 2005. So just barely a year after he passed away, the good battle was won, and the Stephen C Minkin fossil site was actually officially named. Now, for any additional information, and we'll link down below, you can visit the Alabama Paleontological Society right there, and they do have a couple of good links on their page. So, thank you very much, folks, for this little look, into the wide and wonderful world of trace fossils. Thank you.